Okay, so now for this one, it's asked to specify both the electron group geometry and the molecular geometry for a set of molecules. So you can't see all four there, but I'll preface each one by saying what they are. So the first one is CH4. This is my second question. For CH4, we have C. We can start off by drawing our Lewis structure. And I just do this by simply putting in all the valence electrons and seeing if we get nice bonding, which we do. And so this looks like the right structure. Of course, when we draw it into the molecular structure, it's going to be three-dimensional. Okay, so these filled in wedges I'm using to show that it's coming out of the page. The dash I'm using to show that it's into the page. And so our electron geometry is tetrahedral, and our molecular geometry is also tetrahedral, right? So there's of course a table for these, but some of them you just start to remember because you'll see them a lot. So the electron geometry is AX4, meaning we have one central atom and four connected atoms, and so that's tetrahedral. And our molecular geometry is also AX4 or tetrahedral. Okay. The second one, okay. The second one is Ph4 Plus. So again, I'm going to start off with my simple Lewis structure. I can be pretty sure, since it's got the same structure, that it's going to be the same. So it's Ph4 plus, so we're missing an electron somewhere. So phosphorus normally has 5, so right now it has 4. And that does give us nice bonding with octet rule satisfied. And there's only 4 electrons there. It normally wants 5. So that's a positive charge. So our positive charge is sitting on the phosphorus, and we have 4 bonded hydrogens. So making this into our 3D structure. Something like this. So our electron geometry is again AX4 or tetrahedral, and our molecular is AX4 or tetrahedral. Okay. Okay, so then the next one is Ph3. So Ph3. Phosphorus has 5 valence electrons normally, without the positive charge. So there we go. And that bonds up nicely, so it looks good. And so we have this, and so our 3D structure is going to be something like this. Where now our electron geometry is still AX4 because we count our lone pairs in our electron geometry. So that's tetrahedral. But our molecular geometry is, so you might see different notations for this, but I'm going to use just a B for our lone pair, so B AX3. So that means we're only considering for molecular geometry, we're only considering the atoms, not the electrons. And so this is a trigonal pyramidal structure. Okay, so here's one case where they differ. And then the last one is NO3. And again, so there's 5 valence here and 6 valence on each of the oxygens. NO3 minus. And so there's 6 times 3 is 18, plus 5 is 23, plus 1 is 24, so 24 valence in total. So if we try to do our simple Lewis structure, then of course we get something like this. The extra electron we can just add in somewhere to fill up an octet, so that guy's happy. He has 7 electrons around him, 5 electrons, 6 electrons, and 6. So these are neutral. This guy's got a -1 charge. The nitrogen's octet is filled, but these two, the octet is not filled. So we need to fill that up. So the best way is to convert one of these electrons into a bond and donate that guy over there. Or not donate, I guess that's a bad word for this, but move that electron over there. And so we get a double bond here, and then this guy would be, and then everyone would be full octet. So it'd be something more like this. And if we check our charges, so there's 7 electrons here. There's 4 electrons here, 7 here, 6 here. So oxygen normally wants 6, so this is a -1 charge. Nitrogen normally wants 5, so it's a +1 charge. And oxygen normally wants 7, so that's a -1. So -1 plus 1 is 0, -1 is -1. So the whole thing's -1. If we count the electrons, 7, 14, 20, 24, so we're good. We got the right number of electrons, and all the octets are satisfied, and so that looks good too. So that's our appropriate structure. If we draw the 3D structure now, all the electrons are going to try to be as far away as possible, but the double bond is going to constrain it, so it's going to be something more like this. Okay, so our electron geometry is AX3. because there's only 3 bonded partners. And so that's a trigonal planar. And our molecular geometry is also AX3, so trigonal planar. Okay, so those are the 4 molecules the question has to solve. So here's the table. Here's a table like I had mentioned. And so these tables can be found in lots of places, and in your courses you're probably also given one. As I said, you end up memorizing a little bit of the easy ones, but of course the higher ones might take some doing. So draw our structures, figure out how many are around it. And so for CH4 it's tetrahedral. For Ph4 Plus we again have 4, so it's tetrahedral. For Ph3 we have a single non-bonding set of electrons and 3 other ones. So the electron's tetrahedral, but the electron's tetrahedral, but the molecular is trigonal pyramidal. For NO3 minus we have only 3 constituents, and so it's trigonal planar for both electron and molecular. So it looks good. Let's see if that's correct.